There's no charge for this electricity. In this project, we're making a 40-watt hand crank generator from these common household items. For this project, let's see if we can make an emergency cell phone charger out of a cordless drill. I have a USB charger that charges this phone from a USB port. We don't really need the USB head, so let's go ahead and cut that off, then use some wire strippers to remove this outer layer. The shielding can be pulled back, revealing the 4 wires inside. I've done this to both ends of the cable and stripped the plastic from the ends of the wires. Most phone batteries need around 5 volts to charge, and we can confirm that by plugging the USB head into the port and attaching some alligator clips to the red and black wires. Using a multimeter, you can see just over 5 volts of direct current. With the phone in series, the circuit is completed when these wires touch and the phone senses power and lights up. This little black plug symbol shows that it's charging, and it only appears when the phone gets around 5 volts. Okay, let's build our makeshift phone charger. I have a cordless drill I think I can convert into an electrical generator by running it backwards. I'll remove the bit, take the battery out, and looking up into the handle, you can see the 2 terminals where the battery would connect. For testing, I'll attach alligator clips to both of them and then connect the leads to my multimeter. When I pull the trigger and twist the rotating end of the drill, I'm generating around 5 volts, and that's what we need. To make this into an emergency cell phone charger, let's round up a piece of scrap 2x4, a wooden fork, a ball of yarn, a mixing beater, a roll of tape, and some aluminum foil. The first thing we'll need to do is secure the trigger in the on position. It won't work unless this button is fully pressed, so let's use plenty of yarn to secure that, then fasten the drill to the 2x4 with as many wraps as it takes to hold it tight. The mixing beater gets inserted into the drill chuck, and when it's fastened in tight, we can double check there's no slack when it rotates. We'll need the torque setting to be at its highest, and confirm the drill is set to reverse. Now it's time to rig the electrical system. Let's rip this sheet of aluminum foil in 2 strips, then fold them into makeshift wires. You can use copper wire if you have it, but aluminum is still a good conductor, and this foil will work in a pinch. These ends are being rolled to a point, and these other ends folded over to make them a little thicker. Now the flat ends can be held in place under the terminal clips of the drill, and since we made these wires so long, let's use the extra length to make sure they're well separated, because they'll short out if they touch. A little tape will hold those temporarily until we can add some yarn to fasten them in place. The red and black wires are stripped down about 1 inch, and for this phone we don't need these wires at all, so one cut and they're gone. Now the red and black wires are attached to the aluminum leads, respecting the polarity of the drill. In this case, red is our positive and the black is our negative. The wires are secured with some more yarn, and all we need now is some leverage for our crank handle. My wife's salad fork will work, and now that we've got our handle, I'm thinking this is ready for a test. I'll start cranking to see what happens, and look at that! The phone lit right up. It's showing the little plug symbol, so we know this is charging. And if I stop, the symbol goes away. It looks like it's working great, so I'm going to take this inside and clamp it down to a table for better leverage. The crank handle gets inserted, and the system is powered up. The charging symbol is flashing, which means I need to crank just a little bit faster for stable power. And there it is. I'm cranking this at about 100 RPM to develop the 5 volts this phone needs to charge. If I crank slower, the phone won't power up, and if I crank too fast, I risk damaging it. Just for the challenge, I'm going to see how long it takes to recharge this battery from a completely discharged condition. It seems to be taking quite a while, but when I think about it, it takes quite a while even when it's plugged in with a charger. I'm coming up on 3 hours, and I just saw the charging symbol flash off. That means this battery isn't accepting any more charge. It's done. I can disconnect the charger cable, and this phone is fully ready to go. If this electrical generator will charge a phone, I'm wondering if it will recharge a battery. I've added metal magnets to the ends of a rechargeable AA battery so that my alligator clips will attach easily. By attaching the same wire to both ends, we've shorted it out, and the charge is being drained as quickly as possible. And I can feel the battery getting hot. This battery is completely dead now, so to revive it, I'm adding these lead wires in parallel with the system and connecting them to their respective terminals. It takes about 15 minutes of cranking, and it's harder to turn the handle this time because I'm pushing a larger electrical current into the battery. Alright, it's done, and a quick test on the meter shows that the battery is fully charged. Well, that was educational. I tried shorting the system out on my meter and got about 6 volts at 7 amps. That's over 40 watts of power. I also tried hooking up an incandescent flashlight bulb and got it to fully illuminate. A white LED was also tested, and it was so bright it actually hurt my eyes to watch. Well, there's a makeshift electrical generator that you can make in a pinch that will charge batteries, illuminate lights, and generate around 40 watts on human power. And it's free. That's it for now. If you like this project, perhaps you'll like some of my others. Check them out at thekingofrandom.com.